So hey guys, welcome back to the new video. So in today's video we are going to study adjacency matrix. In the previous video we studied about adjacency list. This adjacency list and adjacency matrix are two ways for representation of the graphs. Okay. So first of all we will have a quick recap of what we studied yesterday. So what is an adjacency list? Okay. So in an adjacency list what we are doing is we are pointing the list of the our neighboring nodes in the front of the node. Okay. So for example, consider our node 1. What are its neighbor? 2 and 3. So we are listing it in the front of our node 1. Okay. In the same manner, the neighbors of our node 2 are 1, 3, 1, 3, 4, 5. 1, 3, 4 and 5. So we are listing it over here. In the same manner for 3, the neighbors are 1, 2 and 5, which we listed over here. In same manner for 4, the neighbors are 2 and 5, which we listed over here. In the same manner for 5, the neighbors are 3, 2 and 5, which we listed. 2, 3 and 4, which we listed over here. Okay. So in this manner, we created an adjacency list for which we were using this data structure. Okay. So now we will be moving towards adjacency matrix. Okay. So what is adjacency matrix? So typically, most of the time adjacency list is only being used. Adjacency matrix is used less as compared to adjacency list. So let's see how our adjacency matrix is created. So in an adjacency matrix, we create a matrix which is the size of n cross n, where n is the number of nodes. So over here we are having 4 nodes. So that's why we have created a matrix with 4 by 4, like with 4 rows and 4 columns. Okay. So moving forward, we will see like how the adjacency matrix is created in a brief. After we will code it, we will see in more detail like how each iteration is going over here. So you can understand it in much more better manner. Okay. So let's get started. So over here you can see that 0 is directed toward 1. So we will be taking 0, 0 is pointing towards each other. No. If 0 is directing towards 1, yeah, it is directed towards 1. That's why we have written as 1 over here. Is 0 directed toward 2? Is 0 directed toward 2? Yeah, it is directed toward 2. That's why we are writing 1 over here. Is 0 directed toward 3? Is 0 directed toward 3? No, there is no edge which is connecting 0 and 3. So that's why we have not written 1 over here. Is 1 directed towards 0? Is 1 directed towards 0? No. Is 1 directed toward 1? No, it is not directed towards itself. Is 1 directed toward 2? Is 1 directed toward 2? No, it is not directed. Is 1 directed toward 3? No, there is no edge which is connected 1 and which is connecting 1 and 3. Alright. So moving ahead, is 2 directed towards 0? Is 2 directed towards 0? No. 0 is directed toward 2, but 2 is not directed towards 0. So that's why there is no connecting edge between them. Is 2 directed toward 1? Is 2 directed toward 1? Yeah, 2 is directed toward 1. That's why we are writing here as 1. Is 2 directed toward 2? 2 is not directed towards itself. So that's why we are writing 0 over here. Is 2 directed toward 3? Yeah, 2 is directed towards 3. So that's why we have written 1 over here. In the same manner, is 3 directed towards 0? No, there is no connecting node between 3 and 0. So 3 is not directed towards 0. Is 3 directed toward 1? No, 3 is not directed toward 1. 3 is directed toward 2. Okay. So the same question, is 3 directed toward 2? Yeah, the 3 is directed toward 2. That's why we are writing 1 over here. In the same manner, is 3 directed toward 3? No, 3 is not directed towards itself. So that's why we are writing 0 over here. So this is a very simple coding it fast, and we will see like how each iteration in the code is working. Okay, so let's code it. So here I have listed down the edges of that graph you are displaying over there. So we will be creating a function prepare adj list. Okay, so which will be accepting the edges of the graph, number of nodes and number of edges. Okay, so from here you can check like m is the number of edges and n is the number of nodes. Okay, so this will be things which our prepare adj list function will be accepting. We will be passing it by reference, number of nodes and number of edges. Okay, after this the next thing is initializing the matrix. Okay, so vector of vector int adj matrix, it will be of size n cross n. and we will be initialized with 0. Cool. Now the next thing, we will be traversing our entire edges. Okay, and we will be getting each node from there. This will help in getting the first node, and this will help in getting the second node. Okay, so this one is pretty simple. There is nothing complex in creation of adjacency matrix. So after that, we will be needing a function to print our adjacency matrix. So let's create that. Print adj matrix. It will be needing this adj matrix as an input. Okay, so let's, okay, no problem. For auto I adj matrix, for auto j I, as it is a 2 cross 2, sorry, n cross n, see out j. So after printing a line, we will be moving to the next line. After printing a row, we will be moving towards the next line. Okay, so this is done. Let's call our print adj list function over here, adj matrix, sorry, and here too we have to name it as adj matrix. It is not adj list. Okay, so print adj matrix, we'll be passing our adj matrix which we created over here. Alright, so let's call our prepare adj matrix function. Edges, will be passing all the edges, number of nodes and number of edges. Okay, alright. So is there any issue over here? No, there is no issue. Let me check. I will just go through once. We initialize the matrix. We traveled all the edges. Okay, we made relation between both the edges. Then we wrote the function of printing edges. Yeah, we have to give a semicolon over here. Okay, now it is okay. Now let's run this function. Alright, so we have got this as output. So let's cross check this. Alright, so 0 1 1 0 0 1 1 0, 4 zeros 4 zeros, 0 1 0 1 0 1 0 1, 0 0 1 0 0 0 1 0. So yeah, that's what the output we have got. Alright, so let's move to the next part of the video where we'll be like iterating the entire code. Okay, so I will copy paste this code. Alright, so we'll be going through our entire code. Alright, so first of all, the first step which we did over here was initialization of the matrix. Okay, so we initialized our matrix. We created an n cross n matrix where n is the number of nodes, and we initialized the entire matrix using zeros. Okay, so this was our first step which we completed over here. So the second step was iterating all the edges. So the second step was iterating this iterating this array of edges. So we were iterating it over here. So let's go through each iteration. When I is equals to 0, when I was 0, so what we were getting as u was 0 and v was 1. Okay, so we were checking, so we were marking the connection between 0 and 1 as 1. Is 0 directed toward 1? Yeah, it is directed toward 1, so we were marking it as 1. All right, so when I was 1, the u was 2 and v was 1. Okay, so we were making a connection between 2 and 1, 2 and 1. All right, so when I is equals to c, when I was is equals to 2, when I was equal to, u was 0 and v was 2. Okay, so we were making connection between 0 and 2. All right, when I was equal to 3, u was 2 and v was 3. When I was equal to 3, u was 2 and v was 3. Okay, so we made a connection between 2 and 3. All right, when I was 4, then u was 3 and v was 2. Okay, so we made a connection between 3 and 2. Okay, so in this way our entire graph, our final adjacency matrix was ready, which was like pointing the relation between each node of our graph. Okay, so that's it in the today's video. If you like the video, please don't forget to subscribe the channel. So yeah, we'll meet in the next video. Till then, bye bye.